Welcome back. Now we're finally to Chapter 14, where we're going to look at handling user input. And the scripts that we've made so far kind of do their thing with hard-coded values and that sort of thing. But now we're going to be looking at how we can actually take user input and then make decisions or perform actions based on what the user provides on the command line. So in other words, we're going to be able to write scripts that are in some ways very much like the bash commands that you've been learning. You have the bash commands, you can apply some options, maybe a file name or a directory or something like that, and then something happens. We can make scripts that do similar things to that. This will be obviously very broadly applicable to any number of potential applications. So let's take a look. We're starting Chapter 14, page 365. Really on page 366 we'll look at reading parameters, and I have started work on a file here. You see there's not much here yet, but this is actually the example on page 366. I think it's a good one. What we're trying to do here is to calculate the factorial of a number. What is the factorial? Well, the factorial of 6 is 6 times 5 times 4 times 3 times 2 times 1. Okay, the factorial of 2 is 2 times 1. The factorial of 9 is 9 times 8 times 7, etc., all the way down to 1. Okay, so that's easy. Everyone can understand what we're trying to do here. So how would we calculate the factorial of a number? Well, I'll just follow the code example here. I might change my variable names to something a little bit easier, shorter. So I'll say fact equals 1. We'll make a C-style for loop. You've seen these. So for I equals 1 and I is less than or equal to $1. Talk about that in a second. And then I plus plus. Then what do we want to do? And it's just fact equals calculation of whatever fact currently is times that number that we're counting. Okay, so let's just think about this loop for a second. I'll walk through that. So I starts at 1, and while it's less than or equal to, what is the $1? The $1 means the first parameter after the command that we've entered. So basically, this is called Chapter 14 Test 1. We should be able to type Chapter 14 Test 1 on the command line, space, and then a parameter, which is going to be a number, right? And that parameter is what inside the script is known as $1. All right? So we don't make variables called $1, $2, $3, etc. Instead, those represent the positional parameters that are separated by spaces on the command line. So when you type a command, space, and then you add something else, those are what we call parameters. The first one is $1, the second one is $2, etc., all the way up to $9, and in fact, you can keep going past that as well. More on that in the textbook. If you need 10, 11, 12, they're available, but the syntax changes a little bit. So check that out. I don't think we'll have any examples in our video that need so many. But in any case, when we have gone so far as this, we now have the number, in fact, which is the factorial that we want to output. So how does that work? Well, let's say that the number here is 3. So 3 times 2 times 1 should be the thing, right? So I start with I equals 1. Is it the fact that it's less than or equal to $1, which is 3 in this case? Yes, it is. So I say fact equals whatever fact is, that's 1, times whatever I is, that's 1. Well, that's really easy. Okay. Now then, we iterate again because we increment I, so I becomes 2. Is 2 less than or equal to what's in $1? What was that value? That was 3. So is 2 less than or equal to 3? Yes, it is. So then fact is going to be equal to, and that's not going to work, by the way. I'm just noticing I have spaces here. Yikes. There we go. Okay, so fact equals now whatever it was, which was 1, times $I, which is 2. And so now we do it again. It becomes 3. Is 3 less than or equal to 3? Yes, it is. So now fact becomes fact, whatever it was before, that's 2, times 3 now, which is 6. Now we're done. So fact be the correct value now. So we'll say then echo about the factorial of, and what was the number that it's $1, right? The factorial of 1, in our case, in our example, it was 3, right? Is, and of course, fact, right? So there it is. And I need to chmod. Okay, in chapter 14, test 1. And let's give it the number 3. We'll see that that tells us the factorial of 3 is 6. How about what's the factorial of 7? We start getting up to pretty big numbers. Now, be really careful with this. If you decide to type, the number 800 or something here, things will get wonky really quickly. Here, we'll try it. Yeah, 800, factorial of 800, 0. Why? The numbers got too big to be stored in the 32-bit integers that are being kept here. So as soon as we get above about 4 billion, it's just going to be too big. Okay, so one of the positional variables is pretty interesting here, which is the one designated by $0, and so let's just go ahead and echo that $0, and we can say how about the $0 parameter is $0. Now, will that work? Now I have to escape this $, right? So there we go. And let's see what the $0 parameter is right here. And I'll just exit that, and we'll chapter 14 test 1, and with the number 7, say. And it says the $0 parameter is. So check out what that is. $0 refers to whatever the name is of the file. And notice it's the fully qualified name. So from the root, it's in the home directory, and then that inside that, the directory Perry, inside that, directory scripts, and then here is the thing. So you get the full qualified name of the script that is running in $0. Now, sometimes you might want the script name without all of the qualification. There's a way to do that too, and the way that we do that is with the base name command. Let me show you how that works. We'll say the $0 parameter is this, and then let's try something else. We'll say the $0 parameter using base name is, and we'll execute the base name command using command substitution there, right, on the $0 parameter. So what is that going to do? That should strip off the all of the qualification, the location, basically the path to chapter 14 test 1. So if you ever need the name of the script, then that's a way that you can extract it, or two different ways that you can extract it. So one thing we want to be aware of is it's certainly possible for someone to misuse a script, right? So there are certain things that could be done. One of the most common ones is that I don't provide the required parameters. So notice if I do that, I just type chapter 14 test 1 without any parameters after it. Notice I get a syntax error here. So my script has actually generated an error. And the error is, it says operand expected, error token is the less than or equal to on line 3. Okay, so there's a problem with the execution. What's going on? Let's take a look inside here and see what's going on. Here's line 3. Here's my less than or equal that you see right here under the cursor. And what's the problem here? I'm referring to $1. And it's expecting then, since I'm using a numeric comparison, that there's a number in that place. But in fact, what was there? Well, there was nothing. $1 was empty, so there's no content there. And so I get a syntax error as soon as I try to run that. So a way that we can fix that is we can check before we execute something that might be an error if the parameter wasn't supplied. We can perform some checking, and right now we're just going to do some very basic checking to make sure that a parameter was actually supplied there. There are a couple of ways we can do this, but the way that we'll run this for the first time is let's just use a simple if condition, and what we can say is if it is the fact that $1 has 0 length, then what are we going to do? We'll just say how about echo you didn't supply a number. Okay, and then maybe we'll just exit with error. How's that? So what's going to happen here? If $1 has 0 length, that means nothing was entered, then you tell the user, hey, you didn't supply a number, you exit with an error, we're not going to execute any more of the script. So if we get past that if defy, if we get to this line here, or to the line 4, that means there was something supplied for $1. So very simple error checking, just to make sure somebody supplied a parameter. It's certainly possible they could supply a parameter and it doesn't represent a number, but that's something we'll deal with a little bit later. So now if I do that, it says you didn't supply a number, and then if I supply a number, then I get the factorial again. Now then, what if somebody supplies too many parameters? Like let's say that I say 5 and 6 in this case, and I still get the factorial of 5 is 120, but clearly the user's made some kind of error here. So how would we modify this? Well, let's take a look, and what we could do is change this condition to use another feature. That is, there are certain shell variables in addition to the positional parameters that are helpful. One of them is $, the $sign followed by the pound sign. So let's go ahead and just add this to our list here. We can say right here, echo you supplied $pound, parameters. Okay, so let's go ahead and exit that, run it again, and it says you supplied 2 parameters. Okay, so in other words, $pound gives you a count of how many parameters were supplied, and we can use that pretty easily to say to change this if. So how about we say if it is the case that $pound is, whoops, can't do it that way, right, is greater than 1, then we can say, here, let's change it. I'm going to make it, if it's less than 1, you didn't supply a number, okay, and we can say elif $pound is greater than 1, then we can echo you supplied too many parameters, something like that, right? And then we'll exit also with error. So now if there's less than one provided, we give one message. If there's more than one provided, we give a different message. So what's the third case? The third case is there's exactly one provided, in which case we did not meet any of those conditions, and we'll continue with execution. So that's probably what we want, and if we do that, there's no reason for us to say you supplied how many parameters, because we'll only hit that code if there was exactly one supplied, right? So let's just do that. We'll exit, and if I do that, you supplied too many parameters. If I do that, you didn't supply a number, right? Only if I get it just right, then I get exactly what I'm looking for. Okay, so now we'll talk about this section on page 373 called Grabbing All the Data. And you probably want to read that section, although there are some differences in the way Bash works on different platforms. At least on my platform, the $* that is $**, this thing right here, and the $& this thing right here, actually behave the same on my system. And so if you can try some of the examples and the distinctions that the author is talking about on those pages, but I'm not actually getting the distinctions. So let me just go ahead and I'll show you. I'm calling mine Chapter 14 Test 2. So I made a script here, though, that uses the most useful of these, which is the $& this symbol right here. So I've got a script here that's going to say the parameters you entered using the $& method were, and it's just going to echo these things out. Okay, and then the real value of this. What does it actually do? Let me just show you that. Let me show you that first. So if I say Chapter 14 Test 2, and I give some parameters, 1, 2, 3, howdy, and duty. So there we go. If I just print out $& like I did before, you get 1, 2, 3, howdy doody. So just a list of the things that were on the command line. What good is that? Well, the interesting thing is I can iterate over them. So let me just do this. I could have typed this much faster, couldn't I? But there it is. So take a look at what we're doing here in the loop. So we set count equal to 1. And each time through this for loop, we're going to increment count. So it becomes 1, 2, 3, 4, 5. You can see where we use that. 1, 2, 3, 4, 5. Okay. And so for each thing, we'll call it param in $& ampersand. Okay. That is in all of the parameters. Do the following done. What are we going to do? We're going to echo this literal $& ampersand parameter number, whatever count is, equals whatever param is. Okay. So this is going to cause us to go through each one of them one at a time, and you see we are able then to do something with each one of these parameters, process them independently, do whatever we'd like with it. So this is a very useful way to get one variable. Here's one variable that would allow us to go through a list of parameters. And in conjunction with shift, which we're going to handle next, this could be a very handy way to make a script that allows processing of multiple inputs. So for example, if I have a script that's going to operate on certain files, and I want to do something to certain files, and I allow the user to input one or more file names after they type the name of the script. So it's script name space, and then all the file names they want to affect, 1, 2, 3, 4, 5, however many they want. I can get them all like this and then iterate over each file easily using a for each loop. Another way that we could iterate over the parameters is using the shift command, and there are a lot of uses for shift, but one of the main ones would be iterating over a parameter list when we don't know how many parameters we're going to have. So I'm just going to add it right here. We won't use the $& instead, we'll use shift. So here's what that could look like. We'll set count equal to 1 again, and we'll say while it is the case that the length of $1 is not 0. That's what that means. You might want to go and review those if those conditions if you need to. I think back as early as chapter 12, the chapter on structured commands, right? But while it is the case that the $1 parameter has a non-zero length, then do the following thing, and then we'll have done at the bottom. What do we want to do? We'll say parameter, I want echo, right? Sorry. Echo what? We'll say parameter number, and we'll just use count, okay? Is, and then whatever $1 is, right? We want to increment count so that next time through the loop we'll increase the value of count. So we'll say count equals count plus 1, like so. And then we're going to use this command shift. So what does shift do? What shift is going to do is it's going to basically dump whatever $1 is. It's going to throw it away, and it's going to take whatever was in $2 and put it in $1, and then whatever's in $3 goes into $2, and whatever's in $4 goes into $3, etc. In other words, it shifts all the input to the left, letting whatever's in position 1 fall off the end of the world, okay, and disappear. So it goes into a black hole, and now then all the others are shifted kind of to the left one, as it were. So as soon as I say shift, whatever's in $2 becomes $1, and as long as that's not 0, we do it again, and then we do it again, do it again. So this is just going to basically shift them, keep shifting them left until we run out of input, and then it'll stop. And then after that we can say that's all, folks, right? Something like that, just to be silly. And let's run that one now. Well, let's see. Yeah, that's it. Get some, and there they are. So now then, this output at the bottom is what we just added, right? So parameter number 1 is 1, 2, 3. There's howdy doody. So the same, basically the same result in this particular case, right? But this time we used the shift statement. Now, as you'll see as we go through some other examples here, shift can also be used to shift more than one to the left, and that could be used if, for example, we've already processed the first 3 or 4 items, using some mechanism. They're still there, but now we want to process the stuff after. You could go ahead and shift 4 to the left if we processed 4 items already, and then you've got the rest of the input available starting from index number 1. But more on that a little bit later.